believe that life just self-organized, it emerged kind of as an accident of nature. Well, those who believe in design, that there's a mind behind our world, believe that an intelligent agent shaped the chemical arrangements in such a way for a cell to function. And I'm going to show you, one, that the scientific evidence conclusively demonstrates that life is not the product of natural selection or self-organization or any natural process. Two, I'm going to show you that life shows indisputable evidence of design. And three, I'm going to talk about the engineering revolution that's taking place in biology. Because we're really at the earliest stages of the next great scientific revolution. And because people in Kenya have not been blinded by the Western philosophies of materialism and anti-teleological assumptions, you could help be leaders in the next revolution. So that's what I'll be talking about today. But to begin, we have to ask ourselves, what are the theories of the origin of life from a materialist perspective? Because if you believe a cell just emerged through natural processes, your theory has to explain several steps. The first step is, how do you get the basic building blocks of life? That would be simple sugars, fatty acids, which form cell membranes, amino acids that form proteins, and nucleotides that form DNA and RNA. And proteins are the building block of life, and DNA and RNA are what contain the information, the template for life. Now, in any origin of life theory, after you explain the building blocks, you have to explain how these simple molecules combine into much larger molecules. So amino acids form into long chains, and the nucleotides also form into long chains. Now, anyone who studies the origin of life would have studied the Miller-Urey experiment. It is one of the most famous experiments. And what happened about 70 years ago is some researchers took gases that they believed were on the early Earth, like water vapor, methane, ammonia, and hydrogen, and then they applied an electric discharge, which modeled lightning on the early Earth. And what happened is they produced some amino acids and some other molecules that would have been useful for life. And this was seen as a major breakthrough. There were front-page news, Nobel Prizes, and the like. Now, everything has been downhill since then. Because here's the problem. What that experiment produced, and what all origin of life experiments produce, if they start with simple gases, is tar, or asphalt, which is a very, very complex mixture of countless molecules. In fact, this is a simulation that started with some of the basic building blocks, or the simple gases that would have been on the early Earth. And they modeled what would have happened after several generations of molecular interactions. And what they found is, after about 7 generations, you had about 36,000 different molecules, and only 82 were useful for life. In other words, that's about 0.2% of the molecules that formed were useful. What does that mean? That means that every origin of life scenario ends right there. All origin of life theories that do not appeal to design cannot go past this point. Because the building blocks that you have are surrounded by countless other molecules. So it's far more likely that amino acids or nucleotides will combine with other molecules than with each other, which means you can never go to the second stage of life's origin, which is the building of long chains of amino acids in the proteins or producing RNA or DNA. End of story. What's even more problematic is that the building blocks that you need, things like the sugars, things like the nucleotides, the complex molecules will tend to break down into simple molecules. And even if you imagine that aliens seeded the Earth with countless RNA molecules, which were, let's say, hundreds of nucleotides long, and countless proteins, which would be amino acid sequences, which were hundreds of amino acids long, well, what happened is natural processes would just break them apart into simple molecules. So nature goes in the opposite direction. Now, a person to talk about this is Stephen Bannon. And he's considered one of the leading origin of life researchers in the world. So of all the people on the planet, he would be one of the most knowledgeable and biased in believing that it did happen through some natural process. So extreme bias and extreme knowledge. Here's what he said. Further, chemical theories, including the second law of thermodynamics, etc., suggest that it is impossible for any non-living chemical system to escape evolution and enter into the Darwinian world of the living. In other words, this leader in the field says, based on everything we know about chemistry and physics, based on pretty much every origin of life research experiment that's been done in the last 70 years, points to the conclusion that the origin of life is a physical impossibility. Now, what's amazing is at the end of the paper, he took off his hat as the objective scientist and then put the hat on of a sort of high priest of the secular faith. So he wanted to encourage the faithful and said, but don't lose hope. You have faith that we will one day explain it. Yet he gave no reason for that faith. Now, the basic idea is that natural processes always break living molecules down into simple chemicals. What never happens, naturally, is simple chemicals do not coalesce into complex biological molecules and eventually into life. Nature goes in the opposite direction. Now, I'm going to explain to you why that's the case. So I'm going to explain to you a whole semester of thermodynamics in 5 minutes. Isn't that exciting? I know you just came here wanting to learn about thermodynamics. It's just wonderful. So basically, we can think of thermodynamics as two separate driving tendencies. The first is to go from order to disorder, or what might be more technical, going from low entropy to high entropy. And entropy is very closely associated with probability. How likely is something to happen? So if the state is highly likely to happen, if there's many ways it can happen, in general, that's a high entropy state. If there's only a few ways something can happen, that would be a low entropy state because it's highly improbable. The two are directly related. I'm being very simplistic, but it is good enough for this conversation. Now, one of the most famous calculations for how improbable it is for life to form is Fred Hoyle. He was a physicist that I mentioned in my last lecture. And he said, if you want to understand the likelihood of the cell forming, even if you had all the building blocks in high concentrations and high purity in one place, he estimated that the likelihood of the cell forming was roughly 1 chance in 10 to the 40,000. That's a 1 with 40,000 zeros. He said that's kind of like a tornado going through a junkyard, throwing the trash up in the air, and having a 747 plane fall to the earth, filled with gas, ready to fly. Not likely. Now, what happens is, again, as I want to mention, probability is closely related to entropy. So again, if you have 2 circles, 2 spheres, and you have 4 balls, what's the likelihood that you'll have 4 balls on one side and 4 balls on the other? Well, it's very unlikely. There's only 2 ways that can happen. That's kind of like the origin of life. There's very few ways molecules can form life. While having 2 balls on one side and 2 balls on the other is much, much more likely. Therefore, this is high entropy, kind of like a bunch of random molecules that are not life. So again, probability and entropy are closely related. So people in the past said, because life is so improbable, because it's such low entropy, a cell could not form by chance. The problem is that argument is incomplete, and here's why. You do see what would seem superficially to be highly improbable low entropy states that take place spontaneously. Like when water freezes, it forms ice at low temperatures, and ice is much more ordered. It has lower entropy than liquid water. So why did ice form? Well, the reason it had to form is because the oxygen attracts the hydrogen because they're opposite charges. So the molecules pull each other together to form that lattice. So what happens is the reason ice freezes, water freezes and forms ice, is because it's a lower energy state. The forces pull it together, it takes energy to pull them apart. So you can have low entropy states, or what would seem to be improbable states, if it's a low energy state. And why is that the case? Because when water freezes, it releases heat into the environment, and the entropy of the environment goes up by an amount that's larger than the entropy goes down from the water forming ice. So the entropy of the universe still goes up. There's a problem. Origin of life represents a state of high order and a state of high energy. So that's a problem. It's kind of like if you think of entropy is like rolling dice. Getting life would be like rolling 1,000 sixes in a row with dice. Highly improbable. But what if I came to you and I said, I bet you $1 million or shillings or whatever currency you want to use, a lot of money, that I could roll 1,000 sixes in a row with my dice. Who would take me up on that bet? Why wouldn't you? Because the dice would be loaded. I'm not stupid, I had loaded dice. Now the problem is, the dice in nature are loaded for lower energy states. And because life is high energy and low entropy, it's like rolling 1,000 sixes in a row if the dice are loaded for rolling only once. That's the problem. In fact, there was a professor of physics named Harold Morowitz. He calculated that the probability of a cell forming on the early Earth based on the energy, the enthalpy technically, would be like 1 chance in 10 to the power of 100 billion based on the free energy. 100 million. That's a 1 with 100 million zeros. Again, it will not happen. So there was one more hope that physicists had. They said, well, that may be true normally, but what if you put lots of energy into a chemical system? You just apply lots of heat or lots of energy. What happens is you then get what's called a non-equilibrium state. That's a state driven far from equilibrium because of all the energy. And what you see is you can get self-organizational behavior. That would be like a tornado forming, like a funnel cloud of a tornado. Or that would be like if you boil spaghetti, what you get are roll patterns in your water. That's self-organization, driven by the energy. And people said in the same way, a funnel cloud and a tornado self-organizes, maybe with energy, a cell could self-organize. That's the logic. But there's a problem. And to illustrate the problem, I'm going to use an analogy. Imagine you heard that you can get order from lots of energy. And you go home and you find your house is a complete mess. Maybe your children just had a heyday, maybe it was your spouse that had a wild party, who knows. So you heard that adding energy will create order. So you put gasoline on the couch, you put gasoline on the drapes, and you let it on fire. Will that order your house? Not so much. You would get this, disorder. Because raw energy creates disorder. So what would you need? You need a machine that would convert energy in the environment into a form of energy that's useful for ordering your house. So maybe you buy a robot on Amazon or eBay or whatever you want to buy it from. Now what this robot has is an engine, and it converts either electricity or solar power or gasoline into mechanical motions. So now your robot can help to order your house because you have converted the energy on the early earth into a form that's useful for your purpose. Well, that's exactly what you see in life. Life uses incredibly complex molecular machinery that converts one form of energy into another form of energy. In this particular case, in a cell, you've got a cell membrane, and there's protons that flow through the cell membrane. That causes this rotary motor to turn, and this rotary motor looks like a rotary motor in a car. It's got a stator, it's got a motor, a shaft, a drive shaft, and so forth. It causes the flow of electrons is converted into the motion of this motor, and that motion converts one set of molecules into ATP, which is now useful to power your cell. But the energy conversion requires extremely complex machinery. What happens is scientists have tried to find ways that natural processes could do the same thing. They could convert energy into a form that would be useful for life. The most prominent example of this is Nick Lane. He's one of the architects of what's called the thermal vent theory for the origin of life. And the idea is you've got these alkaline thermal vents in the ocean. You have a membrane that forms over the vent, and then you've got more of an acidic an acidic ocean, more of an alkaline vent. So protons will flow through this membrane that forms for electrons in the other direction, and then one molecule will convert into a molecule with slightly higher energy. Now this has been tested experimentally, and the idea in the experiment, it was a reactor experiment by Nick Lane, is that carbon dioxide could be converted to formaldehyde. Amazing accomplishment. Slight problem. The concentration of the formaldehyde that was formed was very, very, very tiny. So that small amount of formaldehyde could never assist in any biologically useful function. So what that means is that the complex machinery seen in life that converts energy in a way that's useful for life cannot be duplicated by natural processes. Natural processes cannot produce even the tiniest amount of energy needed just to prevent the earliest stages of origin of life falling apart. So you must have complex molecular machinery. But that's not enough. Because if you were to take your robot, going back to my analogy, having energy conversion is not enough. Because back to the analogy, if you have your robot, you charge it up and you let it loose, what will that do to your house? It will break your house apart. Because what does the robot need for you to order your house? A program. Information. Because you need information, lines of code in a program, to tell the robot what to do to order your house. You have to program it to wash the dish, vacuum the carpet, order the closet. So information is necessary to create order. It's essential. Raw energy will not do it. Now, when I say information, what do I mean by that? And Dr. Luskin mentioned a little bit about information, but information is that which reduces uncertainty. Information creates desired outcomes. So let me imagine that I tell you, I have buried treasure that any of you are welcome to take. Isn't that exciting? And you ask me, well, where's the buried treasure? Let's imagine I say the buried treasure is at 22 degrees north, 114 degrees east, and that's approximately this area right here. How many of you think you could find the buried treasure with that amount of information? Not likely, right? Now, if I gave you an extra decimal point, I said instead of 22 degrees, it's 22.3 degrees. And instead of 114, it's 114.2. Now the uncertainty has dropped by a factor of 100. There's much less uncertainty. If I give you a second decimal, it's 100th the area of that. Another decimal, it's even smaller. another decimal even smaller, and finally, if I give you 5 decimal places, I've given you more information, and that additional information reduced the area to approximately this room. You could easily find the buried treasure since I've given you a very small area for which to search. I've reduced the uncertainty. I've constrained the area in which you're going to look. That's exactly what you see in life. Because life, I mentioned, has very complex machinery that produces energy molecules that are useful to life. But that's not enough. Life also has enzymes. And remember, we talked about enzymes. Enzymes are proteins, and proteins are chains of amino acids. And there's 20 amino acids. In the same way, there's 26 letters in English language. And if you arrange English letters in the right way, you create sentences that have meaning. In the same way, if you arrange these amino acids with the right sequence, they fold into the right three-dimensional structures, like this enzyme, and what the enzymes do is they're machines that will force the right reaction to take place. Because if you just have a bunch of random chemistry, you pour a lot of molecules together, what you'll have is incredible uncertainty. Many different reactions could take place. But the information in the enzymes reduces the uncertainty. It constrains the outcome. It forces a specific reaction to take place. So it's the information that allows life to exist. In the same way, the information given to my robot produced the order that I wanted. That's absolutely key. And as was mentioned before, or what is important is you ask how likely is it for one of these enzymes to occur by chance? Well, as was mentioned, Doug Axe is a researcher, and he looked at one part of a very simple enzyme called beta-lactamase. And he found for this 153 amino acid sequence, the probability that a random sequence would fold into a structure that could perform the function of the enzyme was 1 chance in 10 to the power of 77. That's a 1 with 77 zeros. That's like if I marked one atom in a million galaxies. The chance that you could pick that atom purely by chance is a chance of a random sequence of amino acids performing a very simple useful function. It cannot happen because information can only be produced by the mind. And what you find in life is even the simplest possible cell requires hundreds of enzymes because the probability that a random set of chemical reactions would coalesce into something like life has been estimated at like 1 over 10 to the power of a billion. That's the likelihood of it happening by chance, which is why you need the information and the proteins or the enzymes to reduce the uncertainty and to constrain the reactions to allow for life to exist. That's what had to take place. Now, what's happened is despite this evidence that life could not emerge by chance, people that are committed to the idea that it happened by chance through natural processes have come up with all sorts of fancy scenarios for how it happened. So this is one of the leaders in the field. That's David Emer. He has this very complex scenario which includes meteorites, lava, volcanoes, ocean water currents, cycles. It's really quite remarkable. It almost feels like you're watching Lord of the Rings with Frodo going to Mount Doom. Now, what happens though is if you look at any of the steps in this scenario and you ask yourself, could it happen naturally? Well, you could go to an experimental lab, and this is what people like, this is what different researchers have done. And what they've been able to do is reproduce some of the steps leading towards life in these scenarios through experiments. The problem is they can only do it if they carefully control the experiments. They start with highly pure solutions of molecules in high concentrations. They use carefully controlled experimental conditions. They have carefully orchestrated protocols. So in other words, the only way you can move molecules towards life is with enormous levels of investigator intervention, intelligent agency. This is a beautiful quote. It's by Robert Shapiro, who was one of the leaders in origin of life research before he passed away. And he was describing experiments to produce RNA, that molecule that was essential for life. He said about these experiments, the analogy that comes to mind is that of a golfer who, having played a golf ball through an 18-hole course, then assumed that the ball could also play itself around the course in his absence. He had demonstrated the possibility of the event. It was only necessary to presume that some combination of natural forces, earthquakes, winds, tornadoes, and floods, for example, could produce the same result given enough time. High levels of orchestration. Now, to look at it differently, what happens is I mentioned that information in the enzymes constrain the outcome to produce the right reaction. In the same way, the information in these complex experimental protocols, these complex techniques, also constrains the outcomes to move molecules towards life. In other words, what the researchers have shown by their extremely elaborate experiments is that information, a mind, is essential for every single step practically towards life. To put it in a more general term, to go from simple chemicals to a cell, you have to harness a lot of energy. You need energy to concentrate the molecules. You need energy to put them together. You need energy to assemble the structures into complex machines. And what you have to do with this energy is direct it to create the building blocks, to transport the building blocks to the same location, and assemble the building blocks into a cell. Now the challenge is, because every experiment that does any of that requires extremely complex protocols and highly concentrated molecules on the early Earth, any event that would lead to life would be very, very rare. So occasionally, a couple of amino acids might come together. You might see a nucleotide or two in the history of the Earth. But what would happen is natural processes that would happen every instant, working on every molecule, would push everything back towards simple molecules. So if you imagine that aliens seeded the planet with almost complete cells, like 90% complete, maybe some were 70% complete, maybe some were 10% complete, you gave everything you wanted, cell membranes, organelles, DNA, whatever you want. And the aliens just seeded the planet with all this biologically useful machinery. What would happen? Natural processes would break everything back towards simple molecules, and you would have to start again from scratch. Because nature always moves in the opposite direction. And of course, one issue that's rarely talked about is how do you get everything back in the right location? Because imagine that you just by a miracle, an almost complete cell formed. Almost complete. It needs just one more enzyme, one more protein. And this cell is in, let's say, a small pool of water, which is like a cubic meter in volume. And now let's imagine, purely by chance, that enzyme appeared. So you've got the cell membrane, all it needs is this enzyme, and it's in one pool of water that's 1 cubic meter in volume. The challenge would be, it could take 1 million years or more for this protein to even make contact with the cell membrane through diffusion. So long before the cell membrane would find the cell, it would break apart into small pieces. End of story. So this localization problem is one more reason the origin of life could not have happened naturally. Oh, but it gets so much better. Because not only do we know that the origin of life is not possible from natural processes, we also see evidence of design that's so unambiguous, even people that do not believe in design philosophically have to talk about it as if it were design. Here's a great paper. It's Frankenstein or Submarine Alkaline Vent. Who is responsible for the abiogenesis? And it's a two-part paper. In the first part, the authors, like Michael Russell, who's a leader in the field, said, but even those of life's molecular transformations that do run downhill have to be taken out of chemistry's hands and managed by a dedicated macromolecular machine in order to impose conditionally manipulable control over reaction rates and to exclude undesirable reactions, both with reactants and products. On its own, chemistry is far too indiscriminate and uncontrollable. So what they're saying is that normal chemistry will never do anything useful for life. Every reaction, every process requires a machine to make it happen. And then he says, everything has to conform to an elaborate organizational design. And this is what's really key. Life, the study of life, biology, is not a science like chemistry or geology or cosmology. The study of life is reverse engineering technology produced by a mind far superior to our own. So it doesn't even make sense to talk about the origin of life from natural processes. Because like technology, the arrangement of molecules in a cell, the processes that take place, are not a property of the materials that make up the cell. It's like a car. You can talk about the metal in a car, the plastic in a car, the glass in a car, but the physics and chemistry of metal, glass, and rubber cannot explain the organization of a car. The organization of a car is due to a blueprint produced by a mind. And the materials are shaped according to that blueprint, which transcends, which is beyond the chemical and physical properties. The exact same thing is true of life. The molecules in a cell are not arranged based on their physical and chemical properties. They are arranged based on the blueprint produced by a mind. That's why life is like technology. Now, here's another thing in the second part. They say, we claim in particular that it is untenable to hold that life-relevant biochemistry could have emerged in the chemical chaos produced by mass-action chemistry and chemically non-specific energy inputs, and only to later evolve as dauntingly specific mechanisms as a part of evolving all the rest of life's features. So what they're saying is that it is impossible for chemistry with energy to produce life. Now, did these researchers say, well, therefore it must be designed, I should give honor to our creator? Not exactly. Here's how they responded. Instead, we claim it had to have been launched simple and specific, and thereafter had been forced by the site of natural selection to maintain the necessary specificity standard at each evolutionary increment in complexity. More specifically, all devices of life, metabolic and structural, must have been invented by it, in situ, step by step, and while in flight, starting from the simplest possible inputs. And learning itself by trial and error which small changes themselves occurring by chance were useful, each incremental step in this evolution by creeps. Complexity building process necessarily being vetted by the system, both for fitting in and for contributing more utility and cost. Now, I really need to focus on the insanity of the statement, because what we're dealing with is some soup, some chemicals in a thermal vent. It's just chemistry sitting there, two molecules. There's nothing reproducing. So if nothing reproduces, you cannot have natural selection. And the scenarios for how molecules self-replicate like RNA are completely implausible. And I can explain that in the question and answer if you like. So what they're saying is nature just says, well, I know how to build a cell. I'll select this molecule, I will build this molecule, I'll try this, I'll vet this. I mean, that makes no sense. Nature is just physical conditions. What they recognize is that what we see in life requires design, There's an organizational design, there's machines, but they don't want to appeal to a designer, so they smuggle design in through the language of natural selection or self-organization or emergence, but it's all nonsense, fiction. Now, the project that I worked on with some biologists and some engineers is asking how simple can a cell become and still work. Part of it is we looked at research into minimally complex cells. That's like the work of Venter, where he took a bacteria and he kept removing genes until it stopped working. And there's many other attempts to find minimally complex cells. We also looked at studies of self-replicating machines. Like there's work by a mathematician named Von Neumann, where he thought about what must you have for self-replication. There's studies of self-replicating space probes by NASA. There's studies of self-replicating robots. And when you look at these two sources of knowledge, studies of cells with self-replicating machines, what you find is a convergence. So anything that self-replicates, whether it's a cell or a space probe, must have certain functions, certain components. And they would include these. You must have energy production, selective gateways. That means you've got to have portals that allow the right thing in, the right thing out, and block anything else from entering and leaving. You've got to have active transport. In other words, you've got to use energy to force stuff through these portals. You have to have information processing, manufacturing, auto-assembly, automated repair, waste disposal, recycling, sensors, signal processing, and control systems. This is what's necessary for even the simplest cell. Without that, what would happen is a cell would stop working and break apart into simple molecules. And this shows indisputable evidence of design and purpose. Now, what's also interesting is in biology, engineers are to a greater extent working with biologists, and that's resulting in a shift, a revolution, a change in assumptions from undirected evolutionary assumptions to design-based assumptions. And here's a great book that talks about this. It's System Modeling and Cellular Biology. It was put out by MIT. Here's a quote. An often noted reservation against the type of analogies between biological and engineering systems we brought forward states that these two types of complex systems arise in fundamentally different ways, namely through evolution versus purpose-driven top-down design. This is what we see in life, purpose-driven top-down design. What that means, it's kind of like if you build a car. If you build a car, you plan it out in advance. You look at the top level, the top-down perspective, where you look at the major components of the car. I need a steering wheel, a transmission, wheels, a chassis, a passenger compartment. And then you plan and you build every component and every system to work with each other in symphonic harmony with the overarching goal always in mind. That's top-down purpose-driven design, and that's what you see in life. Here's another quote. From engineering, it is known that feedback control plus feed-forward control, enabled by fast and, if possible, remote advanced warning sensing, is the most powerful mechanism for providing robustness to fluctuations in the environment and the component parts. The heat shock response in E. coli appears to employ exactly the same principles. In other words, what the authors talk about is that you don't just see top-down design, but you see the same engineering logic and patterns that humans use in our engineering employed in life. Only life does it better. In other words, it looks like the universe was designed such that certain engineering principles and patterns work, which is why we see the same engineering patterns in life and human engineering. In other words, the best that we can do is what we see in life, unless life does it better. And what happens is, here's a great paper that kind of brings this all together. It's called A Survey of Engineering Models for Systems Biology. And what it says, as a discipline, systems biology shares many characteristics with engineering. In this paper, we identify the cell as an embedded computing system, and as such demonstrate that systems biology shares many aspects in common with computer systems engineering, electrical engineering, and chemical engineering. And what they do is they go through all the systems for the parts of an embedded computing system, and they show how the same function is performed in life, and you see the same interrelationships of the functions. In other words, the blueprint or the design logic of an embedded computing system maps very closely to what's happening in a cell. Everything from processing engines to information code, to memory, to oscillators, to timers, to computing structures, to data specification, to memory layout, to high-level formatting, etc., etc., etc. So again, this is really powerful because as engineers work with biologists, what you'll see is enormous advancements in the science, and it's from a design perspective. So again, what we see is the picture of a mind at the center of life. I just want to conclude by showing you some of the machinery of life. This is DNA replication, which coordinates with multiple proteins, where you have to copy both strands of the DNA in different ways. Bacteria do it a little bit different, but you still have the same basic functions. Now ask yourself, honestly, according to origin of life theories, this was produced through random chemical reactions. So imagine that gunk in your barbecue pit. Imagine the likelihood of this appearing among the gunk in your barbecue pit. Here's another interesting feature, is when you copy DNA, you have to open up the strands, and that creates what are called supercoils. That's that twisting that you see with the DNA. So if you do not remove those supercoils, the DNA can't open up and be copied, and the cell dies. So what a cell needs is a machine that will snip one strand, pass the other strand through the open break, and then repair the broken strand. And here's what that machine is called, a topoisomerase. So here's an enzyme. What it does is it breaks open one strand of DNA, it passes the other through it, it lets one go, it then lets the other one go, and then it resets to do it all over again. Now ask yourself, what's the likelihood that all these amino acids on the early Earth in some pool came together in the right order to produce this enzyme, and this enzyme just happened to find its way to a cell, and the cell opened up its cell membrane and said, come on in, join the party. It entered and then just started to work with the other machinery. That is ludicrous. What we see, again, is a design. Thank you.